pretty much always recorded all the random stuff that I do in my shop, but it really is a ton of work to set everything up and get it to look good. And in my recent efforts to try and get something remotely presentable out of the video, I've realized there's a couple of shortfalls to doing it yourself that I might be able to remedy with a little bit of automation. So to do that, I'm building this. This is a motorized camera slider, and it'll enable me to get smoother moving shots of small items like this, or even larger shots where the camera's moving during a time lapse to make it a little more interesting. So to start, first thing I did was figure out the main components. This is an Arduino Nano and 2 stepper motor drivers. I'm going to solder these onto the board with these sockets. I like the sockets because inevitably when I blow something up by connecting the wrong 2 wires, all I have to do is pull those major components out, and then I can just slide new ones right in. Soldering in the sockets, the first thing I like to do is just lock down 1 or 2 points, usually the corners of the sockets. Then you can remove the components and solder the rest, and that mostly lowers the risk of damaging the components. Don't forget to clean your soldering iron. It seems like every time I come back to this thing, it's so dirty, it takes me like 20 minutes to get it ready. I'm going to fit all the components onto this one board and also wire in a couple other switches. This build is based on a different build. I'll link it in the description. And with a little poking around, you could find a couple different plans to build something like this yourself. Once I have all the electronics soldered together, what I'm doing here is testing continuity. So I'm making sure everything is soldered where I think it is, it's going where I think it is, and more importantly, that the components aren't wired to ground that shouldn't be, because as soon as you plug it in like that, it'll blow something up. This uses an encoder to move around the menu and select items. I've also wired in a couple of override switches for the motors, and that is a motor enable and disable button. The mechanical design is mostly based on this aluminum extrusion. It's something that's used for 3D printers and a bunch of other stuff online, so I get to use standard components like these nuts and this belt tensioner that is also a standard component. There are a bunch of 3D printed components that I've slightly modified, but they're mostly the same as the linked build. First of all, the motor housing goes on this little slider. It is also designed to go on the aluminum extrusion. And you'll notice 2 of the wheels have a smooth bushing and 2 of them have a nut. The 2 with the nut shape are adjustable, and that way you can adjust the tension of the wheels as they slide on the track to make sure it's a nice tight fit. With the top plate on the motor, I can slide the motor and the top plate into this housing, tighten it down, and that whole motor assembly is ready to go on the extrusion. Here I 3D printed a motor mount plate. As it turns out, that wasn't the greatest idea. The cheap steel ones on Amazon are cheap and steel, and I actually had to fight this one a little bit. We'll look at that a little bit later. The whole thing works by using a cogged timing belt, and it's pretty cool because you can slide the belt through the extrusion, it's hollow on the inside, and then clip it to either side of the motor carriage. And these are very simple to lock in place. They slide through a little holder, and what you do is use the toothed wheels, they lock into each other, and then when you put the holder over both parts, the teeth lock the belt together, and that's not going anywhere. And with the belt tensioned, you can see the motion is very smooth. It goes around the motor and the tensioner. And with the belt tensioned, a quick check and all the motion is nice and smooth. I printed the legs from the other build, but while I was in there and changing the files, I figured I'd print some legs with a little logo and add a little flair to this. This is a spherical camera mount to allow the camera to pivot. It uses a 1/4-20 bolt into the bottom of it, and then the top of it has a 1/4-20 thread, which is the standard tripod mount for most cameras. But to use this, I had to design and print a little standoff so that I could mount the standoff to the motor and have room to run the bolt up into the camera adjuster. And that's it for the mechanical assembly. This thing is really simple for how much it can do to add a little bit of motion to your videos. Before I even made it into the testing phase, I've realized a couple mistakes I made. The first is I put female sockets in for the motor leads, but the motor leads also have female sockets, so didn't think that one through. I decided to fix this by de-pinning the motor connector, and it conveniently fit right over some male pins that I could then use to plug into the socket. A little bit of heat shrink should keep these from touching anything and maybe shorten on something inside of the box. Speaking of the box, here's the design for that. It's something I'm going to 3D print. It has a small flange to mount directly to the extrusion. It also has a hole here where the power connector will go through, as well as a set screw for that in the event it doesn't want to stay. Also a channel design to fit the motor on-off switch, and finally a little boss inside where the board will sit. I also printed a lid, and the lid needed some holes for the switches as well as a hole for the OLED screen that I'll be using. And there it is in real life. I think it turned out pretty good. Much to my surprise, all the components fit great first try. But the flange, obviously, isn't going to work. Didn't think that through. When the slider is sitting flat on any surface, the box won't mount. So I either need to lift the whole slider up, which I'm not going to do, or redesign the box. Here's the new box design. I added a couple features, a small channel for the motor wires to go through, a hole in the front to plug the programming cable in, and I moved that mount flange to a more reasonable spot. Also added some cooling holes to the box and the lid, and those look pretty sweet. On to the next problem. It turns out the 3D printed motor mount is not great. It's too flexible and it rubs the belt on the extrusion. So I printed one with a little more support. Let's get that swapped over. That looks pretty good to me, and the motor is a little straighter that way. Finally, I can install everything into the final motor case, tighten the lid on, and plug it in. But first, this is a little bit of copy and paste and a little bit of my own creativity in the code. But I did learn a lot going through this, like using pin 13 on the Arduino. Not good. It's got an LED attached to it, and it doesn't want to be a good input. Recursion in an Arduino program. Yeah, that's bad. That's stupid. Don't do that. That's what the term Stack Overflow means, apparently. And with all the code troubleshot, now we can plug it in. Ooh, fancy, wimpy. Operation of this is pretty straightforward. I like to turn the motors off, and then I can manually move them wherever I want. Position the first motor in the rotation of the second motor. Then you reset your points and turn your motors on. Everything is now zeroed. Then you can use the encoder to go to the capture point screen. Here you can see I've got it set up to capture up to 4 points. And with your motor override switches, you can move the motors wherever you want and capture the second, third, and fourth points. And with all the points captured, now I want to set the time that it's going to take to run through all 4 points. I have this set up to be just a few seconds, or it jumps into minutes when you want to go a little longer. For the first try, I'm just going to run this quick in a 10-second increment, and we'll see how it does. Take it down to run motion, and as you can see, it goes from whatever point it's at to the next nearest point until it gets to one end or the other. I don't know why I picked such weird points for the first demo, but all this does is go from one point to the next nearest point until it hits one end or the other. And if you don't reset your points, you can just go to set time, set a longer time interval after you've run a test. So here we'll go for 30 seconds and we'll try that again. Much slower movement here. And I'm not going to make you watch the whole 30 seconds, so we'll skip ahead to the interesting part. But it's exactly the same, it only takes 30 seconds. And my first try at getting a detailed moving shot, but I found another issue. So from an outside perspective, you can see that the 1.5 degree or so motion of each step of the rotation is actually way too much. It jerks the camera around a little bit, and that turns out to be pretty difficult to take out in editing. So I started down the path of designing my own 3D printed planetary gear set for the original stepper motor, but it turns out you can just buy stepper motors with planetary gear sets, and they only cost a couple dollars more than a standard stepper motor. So I'm just going to replace the old one with this new one with a planetary gear set and move on with my life. And all I really need to do to make this work is print a new base plate for the motor and a cover to lock it onto the base plate. Luckily for me, this motor cover turned out to be a perfect fit first try, so I'll take that win. That whole assembly goes back on the carriage. We'll get the belt reattached, but you might notice that it has a different motor shaft, so I need to turn a new adapter from this motor to the camera. And that wraps up this build. Now I can get some moving shots of time lapses. There's always room for slow motion. You don't need the slider for that, but I do love me some slow motion. Some nice smooth moving shots of small detail parts. And even put some motion into a bigger scale time lapse. This thing's pretty sweet. It's like having your own cameraman. Hey, all right. So thanks for watching. I really appreciate it. I might use this thing for every shot. But yeah, thanks again for watching. Thanks for subscribing. All right, maybe I won't use this for every shot, but it's pretty cool.